And I'm going to start that with the collaboration between Franken Solar and Canadian Solar. So one of our core tenets is the trusted quality that we bring as a module manufacturer, being a tier one manufacturer, uh, but also combining that with the quality of services that Franken Solar provides throughout Canada. The fact that we have very resilient modules also is a big benefit to the Canadian market. So we do tend to lean into that quality quite a bit. Now, where Franken Solar really brings in value in this partnership is helping you as their network choose what is the right product for your installation and whether Canadian Solar would be able to provide what you need. Now, with Franken Solar having big representation in Canada and stocking Canadian Solar modules, we are able to provide shorter lead times and reliable availability of our products. With expert support from both teams, you're able to get personalized help that fits your project needs. And last but definitely not least, both of us have been in the game for quite some time. So by relying on our collaborative products, you're able to have confidence for the long term. Some brief intro for Canadian Solar. We were founded in 2001 in Ontario, Canada, and in 2006 we started being publicly traded on the NASDAQ. Since then, we've had over 61 gigawatts of solar module capacity with 30 gigawatt hours of battery energy storage capacity. We do have a network over 20 countries, so we're going to go into the map in one of the next slides. And as I'm going to go over in the next slide, we have two parts of the company, one being the manufacturing end and one being the project development. So this is what you sort of see here on the middle slide. The part that I do want to emphasize is that Canadian Solar is not an island. We're heavily interconnected and recognized by other industry collaborators, let's say. So that's where our tier one rating comes in from the Bloomberg NEF. We also have the Sustainability Reporting of the Year in 2023 with a Seal of Excellence for Sustainability following in 2024. We're top brand by PV USA and awarded as such in 2024, where in the same year, we were also awarded by Newsweek as world's most trustworthy company. So that's something we really appreciate. Now, we also have some technical accolades that I'm going to go over in more detail when I'm presenting our reliability metrics. On the manufacturing end, which is what we're going to focus on today, we have had cumulative shipments of 150 gigawatts, with 31.1 of them being delivered in 2024. Now, we do have a total system solution approach where we provide inverter system kits, energy storage, and EPC services. EPC services obviously ties more into the project development part of the company, but we also have a wide network of partners like Franken Solar that assist us with being represented in projects across North America. Now, with the battery storage solution being also a part of the company, we are delivering end-to-end integrated battery storage solutions for utility scale, commercial, and even residential applications. So between those, we have had 10 gigawatt hours of total cumulative battery energy storage shipments and $3.2 billion of contracted backlog. Now, here we see all of the areas where we do business, and we also have manufacturing facilities across the globe where you can see it with this little sign here. Now, where our global headquarters are is in Guelph, Canada. We recently renovated that office, so if you're nearby, feel free to give us a visit. And we pair our manufacturing facilities according to the market segment that is being served. So, for example, even though we do have manufacturing facilities in Texas and we're creating one in Indiana, there's no reason Canada should be burdened with any of the additional cost adders that we see with US domestic manufacturing. So Thailand is better able to serve the supply needs for the Canadian market. So rest assured that you're not dealing with any of the cost adders that we've had to implement in other markets in North America, so that we remain competitive there. Now, with all that being wrapped up, I can move us into the module portfolio. So here you see our module portfolio for the year 2025-2026, segmented in 3 different parts. So on the far right, we have a strictly utility module. It's our biggest format, and it also has our biggest wafer. This last line here is the wafer size that we've implemented for each module. And it is stocked with Franken Solar at 720 watts. This is the Top by Haiku 7. So just a very quick intro on the naming convention. Oh, Danny, you're muted, but I can see you.
Muted me. Yeah, I actually wanted to mention that one we don't stock. It can be ordered from us, but there will be like minimum order quantities and longer lead times. Definitely open to selling that, but from a logistics standpoint, it's a much harder module to manage, and it's not a product that is stocked. It's strictly a ground mount product, really, and that's what we recommend it for.
Got you. Yeah, sorry. Misspoke. That is the power class that we'd be able to provide, Franken Solar. But it is perfect for ground mount and ideally tracker. It does have the same width as our Top by Haiku 6 series, which exists in the intersection of commercial, industrial, and utility applications, with a shorter profile than the 7N. So from these, Danny, I am correct that you do stock the 6.2 66 TBH?
Correct. Yeah.
Okay, so this is, thus H stands for high load. You'll also notice it in the module that we are presenting today. And it just means that it performs really well for both downforce and uplift project requirements. So this one is being stocked at 620 watts, and it is designed with the what we call colloquially the 182 Pro wafer size, which is 182 by 210, and we do see some benefits when paired with inverters for this wafer size that I can go when I'm talking about electrical characteristics for the residential. So if you notice here, we have an almost identical product, but instead of -H is -HP, which means that it can support both high pressure requirements and has an elevated hail resilience. So if you do have a project for which you want Canadian solar modules that's in a more hail prone zone, we can cover you. It's just in one of those categories that Danny mentioned. It's not stocked right now, but for the right order size, you could have this module for your project needs as well. Now, last but not least, on the CNI space, we have the Top by Haiku 6 with a shorter format. It's less power, so that comes out to around 590 watts, but it's depending on your application. So let's say maybe you have commercial rooftop, this could be a very good choice. Now, changing format altogether and going to what we're used to seeing in your typical residential rooftop, we have the Top Haiku 6. So this is the second gen Top Haiku 6. Some of you may be familiar with its earlier cousin, the 6.1 54 TMH. This one, we have made some product improvements and we're happy to launch the 6.2 48 TMH. That is being stocked with Franken Solar at 445 watts and also has the 182 Pro wafer that we launched earlier this year. Now, Susan, if you can help me launch a poll to see what feature is the most important to you in a residential module, I'd really appreciate it. So the answers here are high power and high efficiency, high loading pressure allowances, high temperature reliability and improved long-term reliability, or 4, a longer warranty period.
Okay,
Right
the
now
votes are
we,
coming in. Yeah.
okay. Yeah, I can see the data changing
Perfect.
in real time. It seems like for the vast majority, we have high power and high efficiency. And there is also the, the second leader there being high loading pressure allowances. We can give everyone a couple more seconds to participate in the poll if they want. Our third.
It's a big topic nobody ever talks about, I think, with the high loading pressure. I do feel like panels have gotten weaker and weaker over the years, and larger, right? I mean, then
As
I
they
use
get
the
larger and larger, exactly, they are becoming less tolerant. I do have a pretty big section on that, so you will allow me to geek out for a little bit on that.
Perfect.
And feel free to ask any questions at that point. One key selling point for me is that you don't necessarily have to reach the upper margin of the pressure allowances to be able to benefit from an overall module. So I'll explain my thought process behind that when we get there. Okay, so for now we have, and we can close the poll. We have 57% of you with high power and high efficiency, 36% with high loading, and then I can't see what the percentage was for longer warranty, but
it was
that
7%.
7% for longer warranty. So the good thing is that regardless of your answer, Canadian Solar does try to meet the expectations here. So before taking too long, let's go into the technology advantages of this module. There's a few, but I wanted to focus on the 6 that I have here, and without needing to read through all of them, we'll just take them one at a time. So let's start with high power density. Before we do that, I want to explain where some of that benefit comes from, and that's from the cell technology itself. So there are going to be benefits that apply across the board to the products that have adopted the cell technology. So same goes with PERC, same goes with TOPCon, same comes with HAT or other cell techs. And what we see with TOPCon is we do have higher efficiency as compared to PERC. We do have, and all of these are compared to PERC, which is what previously dominated the market. We have improved temperature coefficients, which means that as we deviate from standard test conditions, our electrical parameters are not as much thrown off the loop. And we also have improved reliability test performance, specifically with LETID is light and elevated temperature induced degradation, which is sort of the cornerstone of conditions for solar, right? You have light, you have elevated temperature. That's a pretty big chunk of the reliability testing that we expect to see, and it also has improved potential induced degradation. That is pretty instantaneous. It's essentially when light hits the module, the potential difference that is created has the capacity to induce some degradation. So even though it's instantaneous, it can still make a difference overall. Now, between the various improvements in reliability test performance, we are able to provide improved warranty terms, both in terms of the longevity of the warranty and the degradation rates associated with the warranty that we provide. Now, between all of these, what we do support is that throughout your entire system's life cycle, you do get a better return on your investment because of the higher energy yield that you're expecting to see throughout the project's life cycle. One which way that we're going to quantify it is through our PTC rating. But before we get into that, I just want to give you a brief product overview of the module. So I mentioned the 182 Pro cell at 182 by 210 millimeters. One area where that really helps us is if you're working with a string inverter, you're able to fit more modules. I believe 2 more modules on average as when compared to a shorter wafer. So like, let's say a 182 by 192 or a 182 square. So being able to fit more modules per string means less money spent on labor or potentially even equipment. Now, the next two is where we really made some improvements. We have brought the overall length down from 1800 millimeters to 1762. And we have retained 1134 and 35 as the other two dimensions. The 35 millimeter frame being able to provide us some of that sturdiness that we're going to talk about. The other improvement we made, and this is codified as a better practice, I guess, in the US, but it applies across the board, is we were able to bring down the weight of the panel under 50 pounds. So in the US, we have OSHA, which means that if you pass through the 50-pound threshold, you are technically, as an installer, required to have a second person assisting with lifting the module. Now, even though that's not codified with Canada or in some other country, the risk of having too heavy of a module lifted by one person is there regardless. So if you're looking at I don't know, 28 kilogram panel, then sure, the installer could choose to do it with one person, but the inefficiencies in labor and the risk of it dropping or being damaged could be enough of a discouraging factor that even though they're not required to by code, they may introduce a second person to assist with the lift or have to outsource to some kind of machinery to help bring it up on the rooftop. Now, I do have here that at the power class or 450, it reaches an efficiency of 22.5. I believe that for the 445 wattage that is being stocked, we have 22.3 efficiency. We do have a slightly elevated short circuit current with this wafer size, but we've been pretty lucky in our robust, I guess, network of MLPE and inverter suppliers being able to show some flexibility with some of their models. Now, the key benefits for this module that I wanted to suggest here is that it's really good for rooftop application where there's either space concerns or where there's your typical amount of obstructions. We're able to fit in these modules with a little bit higher probability of proper fitting just because we are 38 millimeters shorter than your average module out there. And we also provide that package in a very neat all black appearance. So we have the black backsheet, we have the black ribbons, we have the black frame, and so on. Now, we've also implemented a multi-bus bar approach that helps us improve the performance of the module by mitigating the risk of microcracks, something that just naturally comes with the area. Now, I did mention that we do get a higher yield out of this module, and that is where the PTC rating comes in to quantify that benefit. Now, PTC stands for PV USA Test Conditions, and it's a rating that the California Energy Commission provides. So in the US, it's a strict requirement, especially if you want to get financed, to have the module that you're using listed on the California Energy Commission. And what they do as an organization is they try to evaluate what is going to be the output of the module that they're listing in conditions that more closely assemble what's going on in the field. So when we say that we have a 450 watt module, that means that when put under standard test conditions, the output of the module is going to be 450 watts. That's the nameplate. However, when put under the sun, like out on your rooftop, you're not going to get 450 watts, and you're going to get something closer to the PTC rating. So that's where we see a very big benefit with Canadian solar modules. I have, in this application example, compared us against another tier 1 manufacturer, where we see that our 450 nameplate yields 427.4 watts under PTC conditions, whereas a 450 watt module from another tier 1 manufacturer would yield almost 2 power classes down, so 417.8. For them to reach 428, they would need to be offering a 460 watt module. Now, whenever you're buying a module, you're paying per watt. So you're able to drop 10 watts in terms of your pricing per module just by choosing a module that has a better PTC rating. I would like to stay on that point and see if there's any questions on that or any comments in general. That's something that is widely available information too. So you can go on CEC and see what the module of your choice ranks on there if it's listed. Oh, Danny, you're muted.
I muted myself this time. That manufacturer A is a very commonly, probably the most commonly used manufacturer in the Canadian market right now, without getting into details, but just FYI for everyone.
We're not going to name any names, fellas, but you know, CEC is widely available, so you can see it too. And someone mentioned thermal coefficients. That's absolutely a big part of it, but you will typically see similar temperature coefficients across TOPCon, and I guess that is where we also pride ourselves in at Canadian Solar, that we have done a lot of work on our TOPCon patents so that we can even marginally improve some of these metrics, because marginal improvement over a life cycle of 30 years applied on the job site can make quite a bit of a difference, and we'll definitely see that when we're talking about degradation rates as it portrays to warranty terms. Now, moving on to the second benefit of the product, it's perfectly sized for residential applications. So this is the older cousin, the 6.154 TMH, the Gen 1 Top Haiku 6. And its absolute max power bin would be 455 watt, 22.3. Now at 450, we're able to bring the efficiency up to 22.5. Now I do want to differentiate between cell efficiency and module efficiency. Cell efficiency is what we were talking about in the very first slide, something that gets elevated just through favor of cell technology itself. What module efficiency is here to measure is the power output of the module divided by its surface area multiplied by standard irradiance. So as we are decreasing the area of the module by maintaining a similar power, we're shooting up the efficiency. that is not where the difference between the modules stops. Again, we have 38 millimeters short. We're able to bring the weight down by more than a kilo. And we do that while retaining the 35 millimeter frame with a back bar that helps us remain at the top for pressure allowances. Now, another maybe not so important to you, but interesting in a design perspective change was that we were able to reduce the number of cells to 48 by increasing the size of the cell. Now, here we're about to go into one of the meatier parts of the presentation. So I'm going to coffee up and it's going to be extreme weather resilience. So that includes temperature, that includes pressures, that includes hail, and so forth. Now, before we go into the pressure allowances themselves, let's consider how we got to that point. Here we introduce 3 modes of mechanical testing that we go for at Canadian Solar. To get into each one, per the standard, Mode 1 is mandated by code and is concerned solely with safety. The standard calls for the maximum load that may occur during the lifetime of the project to be tested times a safety factor of 1.5 as a static load. So essentially provisions that this maximum load can occur without causing any physical deformation to the frame, causing glass fracture or breakage, or I don't know, causing the module to fly off the roof. So it aims to prevent any safety issues in the field without concerning itself with any production losses or similar performance issues. Now, with all that being said, there's more that can happen during the lifetime of the project, right? So despite maybe never encountering that maximum load, you will most likely encounter some snow or wind events that could affect the performance of the module. So on a heavier snow day in the winter, you will have a higher load applied to the module that could lead to microcracking. Now, we talked about microcracking and some of the things that we do to mitigate it, like the multi-bus bar approach, but it's not a specific issue to Canadian Solar. It pretty much just comes with the territory, right? Like when I used to work in out on the field, commissioning PV projects, I saw too many installers stepping on these things. You know, just any amount of force on them is fertile ground for microcracks. So there's definitely some responsibility in how we install these products and how we maintain them, but there's also parts of the manufacturing process that we can implement to assist them. So where Canadian Solar differentiates itself is in all the measures it takes to minimize the effect of a possible microcrack. One of which being the Mode 2 testing, which allows us to better understand how well the module can sustain these pressures and how that affects its performance. So in this mode, we apply the force as a static load first, and then we do dynamic testing. So in essence, cycling the module to see how the crack propagates and how that affects its performance. Quick tidbit here, the multi-bus bar approach essentially means that we're able to minimize the distance that a microcrack can cover before it starts affecting another part of the cell area. So by minimizing or segmenting the cell areas, we're able to stop a microcrack from developing further. And that is the same approach or the same logic behind the half cell approach. By splitting the cell into half, you're able to stop it at half a distance than what it would regularly cover in order to go into the next one. Now, back to testing. As the module is exposed to wind and other phenomena on a daily basis in varying intensity, that module cycles up and down, and that can just weaken the material through fatigue. So even though Mode 1 shows us that we can sustain a maximum load, what we aim to avoid through Mode 3 testing over here is a scenario where over time, due to varying loads, the material is weakened through fatigue. Hence the name fatigue mechanical load testing. So what this testing sequence provisions is a mechanical load testing that goes beyond 10,000 cycles at different amplitudes to verify that beyond the performance aspect of it, the module is reliable and safe to be installed over a period of time usually 25 to 30 years, that it will be installed in the field. So following all of these, and most often before these tests even take place, we use what is called flash testing and EL imaging. Flash testing measures the power output of the module to see if there was power degradation during the test, and EL imaging, which stands for electroluminescent imaging, is highlighted by this photo over here above node 2. And it helps us spot detailed visuals on module performance indicators that wouldn't properly be spotted through the naked eye, such as microcracks and dark spots. So lastly, as mentioned previously, we use a safety factor of 1.5 just to account for variability in material and manufacturing. Now, moving over to some of the pressure allowances that we can boast. I actually, if I can have one moment, because I know you guys use clamping more, right? So this, we have a very detailed installation manual. And if you go on it, you'll find for the residential and both clamping and bolting options, and both of them cover quite some ground. Now, for anything that's not covered in the installation manual, we do have product compatibility letters for like Unirac or other big ragging manufacturers that have some kind of design intricacy that would throw them a little bit outside your regular clamp or your regular bolting method. We do have those available. We have a customer portal on which you can sign up as a user to get info on all of our technical documents, including our compatibility letters. Now, let's say you're using a clamping method or a bolting method that is so unique to your project that's not covered by either. You can work with us directly for us to evaluate your project, and if approved, issue a project compatibility letter, essentially saying that, hey, you can use that, we're not voiding any warranty, etc., etc. Now, for this example, I just wanted to show you how to read the manual. It essentially says that if you're using this type of configuration, the OA, you're able to reach 5,400 Pascal downforce and 4,000 Pascal uplift. If you're using the same way, so depending on how you run the rail. Now, I am going to go more into other special mounting methods and focus on this first one here. So the way I understand Canadian projects, I think 90% fall under this 4-point clamping configuration, for which we are able to boast up to 7,000 Pascal downforce and 5,400 Pascal uplift. Now, the same way that here we give you the type of mounting holes that you can use for bolting, what we'll give you for clamping is a range from the end of the module. So I believe that for 7,000 Pascal downforce, it's 450 millimeters to 550 millimeters. But similarly, you'll see a matrix for your installation method and so on. I'll skip over the other ones or go through them a little bit more quickly because, again, this is the most widely used one. But if you did want to add an additional rail, we can bring the pressure allowances up to 8,100 Pascal downforce and 6,000 Pascal uplift. I mentioned earlier in the beginning slides that you don't necessarily need to be calling for these very high pressure allowances in order to benefit from a module like that. For example, if you wanted to go with very light hardware, let's say using the return flange as a structural member and just use some camo clamps, you're able to cover a wide variety of projects that would fall under this 4,000 Pascal uplift downforce allowance. Similarly, you could go with a rayless option that still gives you a pretty high allowance, something that a module from another manufacturer that doesn't put as much effort into the frame as a structural member or the mechanical rigidity of the module might need a bit of more of a hardware heavy approach in order to be able to reach those, for us, lower pressures. The other way in which we're trying to be weather resilient is through elevated temperature testing. So the standard that we're using here is the IEC 63126, where we've achieved level 1 certification. It's not required in the US or in Canada. It's more so relevant to other regions of the world where extreme conditions it covers are more prevalent. But the idea is to test at more severe testing conditions to see how the module behaves. And if it passes, the expectation is that the module can withstand much higher temperatures throughout its lifespan. So testing and getting certified for level 1 requires testing at temperatures higher than 70 Celsius and going all the way up to 80. That correlates to the map here on the right, where we're looking at pitched roofs. So in Canada, you'll see there's nowhere where we're not covered by this standard. Even in the US, they're just like a tiny little blimp here in Arizona that is not covered by level 1 testing. And that doesn't mean that it's not a good to install or reliable module. It just means that it doesn't fall under the scope of level 1, given that it exceeds the 80 degrees Celsius provisioned. So it's not required in North America. It is a nice to have, especially seeing how some typically cold areas have been experiencing extreme heat events. Now, something that is more prevalent to the weather of both Canada and the US is hail events. So this is where we have where we see some difference between us and other manufacturers in that this module can take up to 45 millimeter diameter ice balls. So those of you who work in hail prone areas know how it all works. It's not something outlined in the warranty, but it is a piece of documentation, all of the certifications we do with PVEL or with VDE, that you can provide to financiers so that you're making sure that when insuring a project, you're not dealing with a long list of premiums that are over securing you because the financier doesn't consider the module you're working with strong enough. Now, obviously, this is test condition, so we're working with a perfectly uniform spherical shape with perfectly uniform density distribution and so on. Nothing stops a hail event out in nature from sending you a bullet-shaped hail projectile that is all front-loaded in terms of density and so on. However, what the financier can quantify is the standardized testing that exists out in the industry. And in that, we do perform very well, and we are certified for resiliency up to 45 millimeters. I believe most of our competition lies in 25 to 35, just for reference. Moving on to the optimized electrical characteristics. So let's take a look at how this module can be coupled with different MLPs. The reason why we're talking about this is this module line is most likely going to be in solar rooftop. And whether it's called a rapid shutdown requirement like it is in the US or something else, there is the wide requirement that calls for the ability to limit the voltage of the array within a limited amount of time. So that de-energizes the array and makes it safer for workers to work on any electrical equipment upstream of the PV array in the event of a fire or a shutdown sequence or anything that really calls for the first responders to be able to access a building safely. So did I miss the speed at which the 177-inch hail is launched at the module? I think here we only offer a snippet, and this is a mechanically equivalent product, so that's why we're able to use them interchangeably. But we do repeat these tests at varying speeds. Sorry to backtrack. I just noticed the question in chat, and I want to get to it. You are able to get the full report that goes into the passing rate at different speeds and different hail sizes, though. So would be happy to provide that afterwards.
Well, I think it's 20 meters per second is usually what the ST standard test conditions, right? I feel like that number is what I have in mind.
I know that they have
because I think some
like
competitors put it
incremental.
on there. I think I've seen it on a different data sheet.
Okay.
Printed it out.
I would have to look at the report because I know that throughout the entire test, we are incrementally adjusting some factors. So, like that includes angle, that includes position of
Yeah.
being hit, etc., etc.
But everyone's
So,
doing the same test. So if another one is doing saying 35 millimeter, you're saying 45 millimeter, it's the same test.
yeah,
Right?
yeah, we're all using IC, presumably, or the the good ones are.
Yep.
Now, back to the MLPEs, we talked about the necessity of being able to de-energize the array. This is the role optimizers and microinverters come to assist with. So the list here on the left represents our compatibility with some of the key players in the market. Now, where we do see a lot of the Canadian solar, the Canadian market landing is with Hoymals and AP systems. I have refrained from using their newer models, models, and not because we're not compatible with them, but because we fall into that, let's say, flexibility zone where some of their new models have a 15 amp short circuit current limit. And for the 445 watt variation of the Top Haiku 6, we are closer to 16. So I think it's 15.8,
I
15.7.
can just jump in quickly. I just got the answer too from one of the competitors, the same one that we mentioned earlier in the meeting. They specified 25 millimeter hailstone at speed of 23 meters per second.
Thank you for looking that up. Appreciate it. So there you go for the hail resilience. Now, just sort of to conclude on the AP systems and Hoymiles, we have heard very positive feedback from installers that they are able to still use their newer models because, I mean, like us, they want to be paired with and pairable with as many products in the market as they can. So, judging on some quality factors, they are able to extend compatibility if it falls within a margin of error. So 1 amp IC typically covers us. Danny,
Yeah,
I'm correct.
we looked it up last time. So all the specifically looking at Hoymals here, all the Hoymals, the new inverter HMS, they're all working just fine with the current Canadian solar panels. No issues. There's quite a bit of headroom actually because they got quite a bit more extra current headroom now.
Yeah, since our last webinar, I have also reached out to them and I'm trying to work with their product management team to see if we can get an official compatibility letter in the works. So that's all on MLPEs. If you are working with inverters, we have the benefit of the added 2 modules per string as compared to smaller wafer sizes. So if you're comparing it to the 7N that has a 210 by 210, the 210 by 210 will be able to fit more, but we're not putting this guy on the tracker. Moving on to the reliability and how it translates into the warranty terms. So in the beginning of the webinar, ages ago, I did mention improved elevated light and elevated temperature induced degradation and potential induced degradation improvements. But as you can see here, we see improvements just across the board. So this one would be thermal cycling for 100 hours of it. This would be light-induced degradation. This would be 1,000 hours of damp heat. This would be the potential induced degradation, and this would just be UV induced degradation just from the sun hitting it. And we see an improvement between PERC and TOPCon in every category. So with that, we are able to boast lower annual power degradation rates when we're talking about our warranty. Now, before we get into the warranty itself, I wanted to make note of another approach that Canadian Solar has implemented so that we can increase the performance of our modules. So we have what is called CSIR technology, and we briefly touched on hotspots earlier, but this process helps us sort and filter cells before they get to module production, but by looking at them through infrared to identify signs of how the cell would act after being encapsulated into the module. And that helps us sort them out before they make their way into actual module production. So if we see that a cell is not going to act well enough after being encapsulated into the module, we're just not going to use it. We'd rather have some loss in some lost cells than be dealing with as wide of a distribution here when we're talking about hotspots. So by implementing this process, we're able to narrow down this distribution and have everything land in the safe zone by doing that preliminary check of what would cause us to jump outside of it, if that makes sense. So even with high power output, we're able to stay in the safe zone by filtering everything that wouldn't work as well out. So on to more reliability stuff and how we actually evaluated. I mentioned before that we work with both VDE and PVEL. PVEL does have its top performers scorecard. This is for 2024. They recently published the 2025, where we're also in there. And that is reserved for manufacturers that consistently test under 2% degradation for all of these tests. So thermal cycling, damp heat, mechanical, hail, potential induced, etc., etc. So you'll notice here that the only one that we're missing is pan files, and that's not because they didn't like how our pan files perform. That's because we don't send our pan files to PVEL. We send them to TUV Berlin, which is a very priced, let's say, third-party validator of a lot of reliability metrics, not only for the solar industry. I was blowing up my inflatable kayak the other day, and I saw it certified by TUV. So they work across the board to make sure that when a company says that, hey, we have a good product, they're the ones to put their stamp on it. And that's who we use to qualify our pan files. Aside from the reliability reports that we have through our long-term reliability program, which are a very hard read, honestly, even for us in technical fields, we have the bankability report. I would call it an easier read because it gives you a lot of descriptors and a more cohesive text that walks you through our processes, our manufacturing facilities, our BOMs, all of that. But it is 130 pages. We do provide it for you. So if you want to take a look at it, you're more than free to. When I joined Canadian Solar, that was my, get started reading. And we've used them for TOPCon to review over 80 tests across 8 bombs. Now, this is a bit of an outlier in the industry. Most companies don't choose to add extra tests into their sequences, because where you add more tests, you add the possibility of a mishap, of whatchamacallit, an outlier in your performance that can bring your overall baseline down. We haven't seen that with Canadian Solar, and we're just as impressed as DNV, to the extent that I do have a tidbit here from Dr. Partvat from DNV, that where he mentions that the rigor and extent of Canadians' quality systems, testing, and manufacturing serves as an example for the entire PV industry. So that's something that we have very close to heart. And if you ever see us being overconfident in meetings, it's because we have very strong partners that validate this confidence in apparently 130-page documents. So if anyone wants to take a look, would be more than happy to send it your way. Now to the promise part of this section, the warranty and how all of these reliability metrics tie into it. Now, we do have a 25 years product warranty and workmanship. That does cover rooftop application. It drops to 15 years if you're doing a ground mount. And we do have a 30-year performance warranty. Now, if we go over to this part of the slide over here, we see that, so for the lower curve is what we expect with PERC. So first year degradation is 2% with PERC, 1% with TOPCon. Where we see most of the difference come from is from the annual degradation from then on. With PERC, it's 0.55. With TOPCon, it's 0.4. And you may say 0.15% marginal. Over the course of 30 years, and I say 30 years because with all of the TOPCon benefits, we're able to extend to 30 years, we see that we go from about 80% to 87.4%. Now, I say 80 because I'm extrapolating the PERC warranty to 30 years, but in reality, PERC warranty only gets you to 25 years of performance warranty. So this is, again, third-party externally validated, and we're able to provide that to your financiers so that they can have the confidence in your project that we have too. Now, last but not least, we do have the maximized space utilization as a core benefit of this. It does tie into what we called perfectly sized for residential installations, but with some more tangible examples. So here we have product A with 500 watts. We're not going to name any names again. We have product B with 450, and we have our product with 445. Now, obviously, we're the lowest of the three in terms of power class, but that doesn't stop us from having a better efficiency than product B at 450 and blowing them out of the water in everything else. So in terms of max downforce, product A is the only one that can reach us. But they do that at, in my opinion, a pretty prohibitive size and weight. We see that being almost closer to what we would sell as a commercial module than what you see as a standard resi in the market. Now, that also reflects on their weight, being 28 kilograms as opposed to 23.6 with product B and 21.8 with us. Where we're also better is with a nominal module operation temperature that allows us to perform better in warmer conditions. And also in the product warranty length, where we are matched by product B and blow product A out of the water. Now, this number makes sense because that is more akin to what we use for our commercial modules, right? It's you do get the better power, but you don't really get it in a package that is specifically tailored for residential applications. And we can see the first example of that with a roof in Calgary. So, pretty big roof, not a lot of obstructions, generally a good one to test that. Where we see that for product A, you can't fit two portrait rows, one over the other, no way. In this design, just to keep the system size a little bit more equal, I've added a row of landscape, but in reality, I know many installers and customers that would rather just deal with one row of portrait and scratch any benefits that they get from the landscape. They don't want to incur the elevated racking costs, and can't say that I blame them for it. Now, product B might have enough space, but not without really going into the safety setback that is needed at the end of the array, closer to the eave. With our even marginal 33 millimeter improvement in terms of length, we're able to get another 66 millimeters between the two rows, which means that we're able to fit it. It's a tight fit, but we're able to fit it while maintaining the safety setback. And with that, we're able to boast a system size that is quite a bit higher from both of them. Taking another example with a little bit more of a complicated roof in Richmond, British Columbia, where we see some more odd shapes, some more obstructions and whatnot, where we can't get too close to these lines, or I guess we can get close, but we can't cross over. And here we come out with something like this. Now, product B and our product will have the more similar layouts, but because of how we're structured, we're able to fit 5 and 5 here without crossing over. Whereas if I had gone over here, the CAD tool didn't actually let me add another module there. So even here, we see that we get the higher system size of all three. Now, I haven't gone into the financials of this because they will vary installer to installer, site location to site location, and so on. But I did want to highlight that because we have this marginal improvement in the length of the module, we're able to fit in some tighter spaces that can be particularly valuable when we're working with either an odd shape or an obstruction of any type. Now, last but not least, I just want to summarize all of the key benefits that we brought up today, in that we do offer in this module a very power dense product that is packaged in an aesthetic combination of features that would bring value to any homeowner. That's just where the standard is set for residential applications. It also comes with strong reliability, both in terms of what can be translated into warranty terms, but also in terms of what it can take in terms of pressure and hail reliance. And it's a very easily combinable product, just both across racking manufacturers that we work with and MLPE manufacturers that mobilize in the sector. Now, all of this is going to be backed by a 25-year product warranty for rooftop applications and a 30-year performance warranty with the terms that we talked about earlier. So with that, I want Susan's help to launch the final poll, which is what features should be improved further for our next residential module? Similar format and answers. Your first choice is high power and high efficiency. Your second one is high loading pressure allowances. Third is high temperature reliability and improved long-term reliability. 4 is longer warranty period. And 5 is none. This is the module I need. Susan, I'm staying out of this one, so I can't see the results. But when we can,
Oh,
when we close it out, I don't want to muddy the
um,
data, you know.
yeah, so far, 70% is at high power and high efficiency. Next is high temperature and reliability and improved long-term, reliability. And then 10% said none. This is the module I need.
To the 10%, thank you. To the 90%, your feedback is always very appreciated when we're going back to work on our next gen modules with R&D. And I will say, to the temperature coefficients, I don't think there's many that go above us, or at least not without some kind of factor bringing them back down to earth a little bit. So between our NMOT and so the nominal module operating temperature and our temperature coefficients, I think that that is a very strong selling point for this module, and one that, if it's important to your customers, you have more than enough data to back you in your selection of Canadian solar as your choice. So with that, we come to the end of the webinar.
Awesome,
Are
Danai.
there any questions that we didn't get to cover? If not, I just wanted to point you to the sales teams that can better assist you if you have any questions, if you have any projects where maybe you're in between products. We do have a very active sales team, and I can tell from my team a very enthusiastic product management. They drag us into calls all the time, whether it's with customers, whether it's with financiers, third-party technical teams. Sometimes, because we're more in of these more technical processes, we're able to explain them a bit better, and we're more than happy to do so as your project requires. So with that, thank you to Frank and Solar for hosting us. Very happy to continue our collaboration with you.
Thank you, Danai. No, thank you everyone for showing up today, and it's a great meeting. Thank you.